because we have a quiz tomorrow. Yesterday was a review. Today is also a review. So I have the homework out, and we'll go over those. And we'll take care of that. Cool. And you said number 8. Was that a correct one? All right. Let's see what number 8 has in store for us. So I have 4 square root 3, and then plus 5 square root 15. Does that look like the right one? Yep. All right. So I'm going to distribute here, and being that the 4 and the 5 are both outside, that's going to give me 20, and then the root 3 comes along for the ride. And then on this one, I'm going to get plus 4 root, and you can go 3 times 15, I guess, in this case, if you'd like. And we'll take care of that. McCoy, you have a quiz you need to finish up with me. A couple of them. So can we do it sometime this week, you think?
Yeah.
Sweet. Just come in on one of your off periods. If I'm in a class, you are welcome to come in here. Thank you. I'm going to unmark you from being absent. Let's see. There we go. Present. Okay. Let's see that. All right, so continuing with this problem a little bit. I don't think there's much more I can do with this for right now. But this other one, I'm going to break down to 9 times 5. The reason I'm choosing that is 9 is our biggest perfect square. So the square root of 9 is 3. So that 3 would get multiplied there. So I get 20 root 3 plus 12 root 5. And because I have 2 different radicals, I can't go any further. So that would be your answer. Yeah. 15. Yeah, thanks for asking on that 15. I won't test you on this one. As soon as you understand what the exponent 1/2 means, the 1/2 power is the same thing as this, which means I just get 5. So the 1/2 power as an exponent means you're talking about a square root. Okay, but I will not put that on the quiz. Okay, yeah. 3? Is that what you said? All right. Number 3, we got root 28 minus root 63. So I can't do anything with those right now as far as subtraction goes, but I think I could break this down to 4 times 7, and I think I could break this down to 9 times 7. And the reason I chose the 4 and 7 and the 9 and 7 is the 4 is a perfect square. Good, yeah. Square root of 4 is 2, so that gives me 2 square root 7. Square root of 9 is 3, so that gives me 3 root 7. So then you go 2 subtract 3 gives me negative 1 root 7. So that answer's fine, or you could have the answer be like this. Either answer is totally appropriate. Your choice how you want to write it. Anything else you'd like to go over? 6. You got it. Number 6, we have 5 root 2. The whole thing is squared. Okay, this means I have 2 5 root 2s that I'm going to multiply together. Yeah, oh, absolutely. Cool, yeah, that's a great way to see it too. Outside gives me 25. Inside gives me root 4. That's a perfect square, so that becomes 25 times 2, which is 50. Just listing all the steps. Of course, you could do those in probably less steps than I did, but I was just trying to show you the thought process. 11. Root 140. Oh, were they? Oh, okay. Yeah. Is that today's? Oh, I put it in for you. You were here. Because we were I actually was running about 5, 6, or about 7 minutes delayed so I just said, if you're here, so when I saw you come in, I put it in automatically for you. All right, so this is a perfect square. That gives me 12. This is a perfect square. That gives me 9. This is a perfect square because it gives me x to the third. You take half of it. This one I would break down to y squared times y. And this is a perfect square. Then that gives me a y. And then this is left behind in a radical. So I'd keep it just like that for right. Oh, actually, I would take it one step further. I can go there. Yeah. So 3 goes into that 3 times, 3 goes into that 4 times. So I get 4 over 3, x to the third, y, root y. And I'd call that good. Anything else, friends? Happy? Content? All right, if you missed yesterday, I handed out some notes, so you can come up and grab those. So have your notes out from yesterday and go to the number 7, if you don't mind. Right there. So we're about a page or so into that. So find SQE7, and this is more review. More review is going to take place. All right. So, would somebody tell me how I could break 80 down with the largest perfect square? What do you think? Anyone recall? 8 and 10, but I don't have either of those perfect squares. What do you got one?
16 and 5.
Is that what you're going to say? 16 and 5, yeah. So I'm going to break it down to 16 and 5. Now, if you don't see it that way, that's okay. Realize you could break 80 down to 2 and 40. You could break 40 down to 2 and 20. You could break that down to 2 and 10, break that down to 2 and 5. And 1, 2, 3, 4, that gave me the 16. Okay? And then I'm going to break a to the 5th down to a to the 4th times a and then b to the 1st, right? So, is 16 a perfect square? If so, what's the square root of 16? 4. Okay, so I took care of that. Is a to the 4th a perfect square? And if so, what's the square root of it?
A squared.
A squared. You take half of the exponent, right? And then I'm left with 5a and b. Of course, you can have a and b raised to the first power if you'd like. But that's the answer. All right. Let's pick on people. I'm not picking on people. I'll call on people. All right. Ready? I'm on this top problem. And this one right here. Josh, can I multiply outside, outside?
Sure.
And if I multiply outside, outside, what do I get? 6. Josh, still picking on you? Should I multiply 12 and 6 together to get 72, or should I just break down 12 and 6? It's your choice. Okay, I would break 12 down to 2 times 6, which is 2 times 3. Agree? I would also break 6 down to what? 2 and 3. And then, because I have x and x, what is x and x going to be? X times x or x squared. Okay. All right. Thank you, Josh, for letting me pick on you. Jason.
I have a question.
Yes.
Would you multiply the 3 by those two? Like 3 times 6x squared? 6x?
The outside 6?
The outside 3 to the inside 6.
Yeah, I can't multiply outside to inside. Yes, if something's stuck inside, it can't come out to play.
Okay.
Okay. All right. Hey, Jason. Does this give me a perfect square? And do these 3's give me a perfect square? So 2 times 2 is 4, right? So square root of 4 is 2. 3 times 3 is 9. So square root of 9 is 3. So now outside, I'm going to have the 6, a 2, and a 3. And Dan, is x squared a perfect square?
Yeah.
So what's the square root of x squared? X. Okay, so I have that outside. It looks like I just have this 2 behind. So let's multiply everything outside. So 6 times 2 is 12. 12 times 3,
36.
36, and there's an x that comes along for the ride, and then a root 2 that's also in there. That one's all done. How do you feel about those two problems? A-okay? Anyone stuck? All right. Let's move down. Max, is this a perfect square that I just underlined? Yeah, what's the square root of 81? Okay, so now I wind up with 9 over root 7. And we said a while ago we don't like to have a radical in the denominator. Agree? Okay, so I'm going to multiply top and bottom by root 7, root 7. So on top I get 9 root 7. Selma, root 7 times root 7 is root 49. So what's the square root of 49? 7. And I cannot reduce the 7s because one is outside and one is inside. Okay? All right. Hey, McCoy, this last problem up here, can I add these together as they sit?
Squares.
Yeah, can I add the root 50 and root 75 together? No, I got to break it down, right? So, McCoy, what do you think the biggest perfect square of 50 would be? Yeah, 25 times 2. Good job. And so the square root of 25 is what? 5. So that becomes a 5. What does this 5 and this 2 do then when it comes out? Multiply. So I get 10 root 2. Do you agree with that, my friend?
Yep.
All right. All right. Second question for you, McCoy. Can I break 75 down?
Not to a perfect square. I think.
What times what gives me 75, do you think?
40, 35.
If I add those together, you're absolutely right. But what if I multiply? Listen to Dan. Say it, Dan.
25 times 2.
Do you agree with this, McCoy? Does that seem okay? All right. Square root of 25 is what, McCoy? 5. So I get 5 root 3. So, Sire, is 10 root 2 and 5 root 3 simplified, or can I add them together? Are these like terms? I'm not dividing anything. I'm just asking, are those two right there, root 2 and root 3, are they the same thing? No, so they're not like terms. So that's my final answer. Okay? Move that down a little bit. Friends, that first page, those first 4 problems, do you feel comfortable with it? Okay. Now notice, my friends, did I take the square root of any number and get like some big old decimal?
No.
No, so we won't do that on the test tomorrow, okay? Or the quiz. And it's only 12 questions. I thought it was 15. So I shaved off 3 questions since I told you last.
Can you put in 3 bonus questions?
3 bonus questions.
Extra credit questions.
3 extra credit bonus questions. Wow. You got 100 million points for everybody.
What about the people who didn't come?
Oh, they missed out. So you all get A's for the semester. There were people who didn't show up get F's. And that's recorded. Now you can use it against me.
They use.
That is just sarcasm, my friends.
They lose 100 points.
All right, friends. What do we think? What do we think about this next question here?
Would you be multiplying those two?
Yeah, because inside is going to multiply together. And this is one of the cases I'd probably multiply together to get 36, because 3 times 12 is 36.
Perfect square.
Perfect square. What's square root of 36?
6.
And then I can multiply those together. Hey, where did the square root sign go? Well, I took the square root of 36, so there's no longer a square root sign.
Or you can put a square root 0 if you don't like it.
Ooh, careful. You put square root 1.
Square root 1.
If you put square root 0, square root 0 is 0. 0 times 12 is 0, and 12 and 0 are 2 different numbers. But I like your thinking. This next problem is distribute. So I can multiply outside, outside, so I get 8. I can multiply inside, inside, so I get root 18. Agree?
What about negative?
The minus comes along for the ride. And then I have a 2. and then I'm going to multiply inside, so that gives me root 24. So root 18 and root 24 are two different numbers. So I cannot subtract these as they sit, but it is possible we might be able to break 18 down. Friends, what is my biggest perfect square that goes in 18? So, Phil. 9 and 2. Okay, square root of 9, Phil? 3. So 3 times that outside 8 is going to give me a 24 root 2. Agree? Then this minus comes down for the ride. All right, friends, what's my biggest perfect square that goes into 24? 12 and 2. 12's not a perfect square, though. Though I agree, those are factors. 4 works, right? 4 and what? 6. So I'm looking for the biggest perfect square. But if you have to break that down to, if you have to break 24 down as 12 and 2, you're totally right. Just realize it breaks down to this. And this 2 times 2 times 2 times 3 is where this all comes from. Hey, square root of 4 is what? 2. So that 2 comes out and gets multiplied with that 2. That gives me a 4. I have a root 6 left behind. My friends, is root 2 and root 6, are they the same? No, so I cannot add or subtract them. They don't change at all. Multiplication, you multiply outside, outside, inside, inside. How do we feel, friends? There we go. Yeah. I want you to break the green down to the red blue. I want you to just, you're absolutely, so this would be a 3-point problem. If you left it right here, you're going to get 2 points off. Actually, you get 1 point off, probably. Because if this is the correct distribution, that'd probably be worth 2 points. And then breaking it down to get to here, that'd get you their third point. I think that's probably how I think about reading it. Cool. All right. Moving on. Okay. I don't like a radical in the denominator. Yeah, top and bottom both get multiplied by root 2, so I get 14 root 2 on top. Hey, what is root 2 times root 4? Or what's root 2 times root 2?
Root 4.
Root 4. What's the square root of 4? 2. So that 2 gets multiplied with that, so I get 6. Outside, outside, I can reduce. So 14 and 6 are both outside of radical. What number goes into 14 and 6? 2. So that gives me a 7 root 2 over 3. Yeah. Notice I did not reduce inside to outside at all. Okay? Next problem is nicely done because what's the square root of 9? 3. So that gives me square root 5 on top. No longer a square root 3 on bottom. Done. Yep. It escaped from the confines of being inside. Jay, question? Yeah, itching your head. Itching? All right. Let's see. Root 20 breaks down, I believe. What's my largest perfect square that is part of root 20?
4.
4. So 4 times 5. The reason I didn't use 2 and 10 is because 2 and 10 aren't perfect squares. Though you could break it down a little bit like that. What's the biggest perfect square with 8?
4.
All right. Square root of 4 is 2. 2 times the outside 2 is 4, so I get 4 root 5. Minus square root of 4 is 2. 2 times the outside 5 is 10. And then I'm left with the root 2. Is root 5 and root 2 the same?
If you're insane, it is.
If you were insane. I don't think I'm insane. I might be, though.
Yeah.
But I think if you think you're insane, you're really not insane. It's the people that don't think they're insane that might be insane.
It's like narcissism.
I think that's what I learned from abnormal psych. Nice 300 level psych class. For those of you who don't know what a 300 level psych class is, it's a junior year in college. I took a lot of psych classes. I thought it was cool. Then I realized I wasn't goofy. Now, I don't see on 108 my biggest perfect square right off the bat. So I might break 108 down just by like doing like kind of a factor tree. So I know that 2 times 54 is 108. Agree? 2 doesn't break down any further, but 54 does. 54 becomes 2 times 27. 27 breaks down to 3 times 9. 9 breaks down to 3 times 3. So 108 is the same thing as 2 times 2 times, whoops. Try and have nice things, and I'll tell you, just break them. All right, so 2, 2, got both of those. 3, 3, 3, got all three of those. All right, so now I'm just looking for pairs because pairs make a perfect square.
You got 2 pairs.
I got 2 pairs, so that's a perfect square. That's a perfect square. If I take the square root of 2 times 2, square root of 2 times 2 is square root of 4. Square root of 4 is 3 times 3 makes a perfect square. Square root of 3 times 3 is the same thing as square root of 9. What's the square root of 9? 3. So outside I have 2 and 3. They don't have a radical anymore. And then I get a 3 and then multiply outside. So I get 6 root 3. Yeah. Do you see a different way to break 108 down? Let's see. 4. 9 times 6 times 2. Or we could do 36 times 3, I guess. If you saw that as a perfect square. I didn't see it right away. But then square root of 36 is 6 root 3. So that's still the same answer. So yeah, there's definitely alternative ways we could see it. Sometimes if we don't see the perfect square right away. Yeah. 3 times 3 times 2 times 3? No. Square root? And so hang on, say it one more time. 3 square root 2 times. Oh, you mean like have this flip-flopped? So have this as an answer? Oops. Ignore that. Could I have this as an answer? Let's see what you got. Ooh. Oh, it's flip-flopped. So the root should have been on the 3, not on that. That should be outside. Oh, okay. I see what you did. Okay. You just had them flip-flopped. Can I move forward? Or is that it? That's it? There's nothing more? Oh, boy. Okay.
And we don't have that weird method.
No, so we still got a few times left. Let's see. Let's do this one. Will you try this one at your desk, please? All right, put it on your notes. Try that one. That one's a little more challenging, but it'll be good to look at. See if you could try it. Write it down, and in about a minute, I'll start writing down the steps. Everyone else has real easy. All of the ones on yours are just like this. Is that okay? Okay, cool. So once you have it written down, and I'll start writing it down in a sec. That's the answer I came up with. Can you make your answer look like that?
did you get the 3 from? Oh yeah, never mind.
Do you feel okay about that? All right. What about try this one? Try that one. Once you get done, take a look. Does my work look similar to what you have done? Questions on that second one? Happy? Sarah, good? Yeehaw. Can I move on? All right. See if you can figure out this one. See if you can try that one. So I gave you two different ways to look at it. Do one of the two ways make sense in your math? I'll put all the squares up for you, definitely. Will you remind me tomorrow, though?
Yeah.
Thanks.
I just turned it into 8 times 9.
Oh, cool.
Times 2
Cool. Yeah, if you break 72 down to 8 and 9,
Did you get 2 points for something?
yeah, so you realize you have that and then this. That totally works. Cool. I like that. All right. Try this one. See if you can figure out that one. Yep.
Sorry,
You got the answer? What do you got?
6 for
Yeah. Love it. As you get done, take a look at what I have and see if you agree. And then here's another one to try. Yeah, I realized this square root of 4 is 2. And then 2 times that 3 is absolutely what I did, yeah. Your answer matched mine, right? Cool. Try and break down root 125. See how you do it. And does your answer match my answer? Does your work look like mine? Some of you might have also realized this was this, which that gives me the 5 outside. So 2 different ways to look at it. Both are totally correct. Oh, good. All right, so friends, I would think for tonight, look over notes from Monday and Tuesday and any work. Tomorrow has a quiz of 12 questions. We have time tomorrow to work on a few things. Did anyone want actually paper homework for tonight? You sure? Okay, so would you take a look at that? Now, friends, also, make sure if you do owe me something, some of your grades are not reflecting on what you actually know, because if you have a test or quiz that you hadn't gotten done, it's sitting as a 0 in the grade book right now. So if you came in and let's say you're like, oh, I don't think I can get 100% on it, well, that's okay. You can get a higher percent than 0%. I promise that.
That's top line.
Yeah, you put your name on something, you get at least a 1%. I'm kidding. It's like a 3% for your name. If you get the period right, that's another 4% you add to it.
What about your last name?
Last name, as long as it's spelled incorrectly, 18% more. So, yes, sir.